Take it away.
All right. Thanks very much, Julius. And Johan is actually the CTO. He's probably traveled the furthest from Sydney, Australia. So there you go.
Thank you.
All right, let's get right to it. And I am going to give away some money at the end. The fake money, the stuff that you might want before tomorrow. I'll ask a couple of questions. So if I don't, remind me, and I'll come back to that. All right, shall we? Looks like we've got to get started. So here's the question. This actually, I pulled this off the web because it's so classic. I'll read it to you just in case you don't want to have to read it. So this is a question that an IT guy asked. I was asked to capture all of our fiber data. I work in IT and we run and own all the fiber to all of our facilities. We have a spreadsheet of the start and end connections. So they obviously then said, well, the first thing that came to mind was this is essentially a geometric network using fiber lines and splices and volt boxes, etc. I know we can create that the data visually and show a fiber network looks like, but I was curious if I could perform simple analysis like a trace route or identifying points of failure and services disruption. Any of you in that kind of stage? All right, I see a few folks. So let's just start. So the focus of this is really what's involved with the fiber network? What are the challenges of storing that kind of information? So a lot of people will have this, especially if they're also doing electric networks or whatever. They'll have the start and end and maybe some segments. And that's often their network. Sometimes the spreadsheet's a little fancier and has some of the steps in between, but essentially in a spreadsheet where they've got the segments. So one of the replies to that earlier question was, this guy, obviously been around the block a few times, says the data models for fiber management are designed around connecting each fiber color pair so that the organization can trace out light paths from one end to the other. It says one fiber bundle has multiple fiber tubes, and each tube carries multiple pairs, each with a color designator. And then they obviously started, which is then the classic. I drew a splice of 24 pairs in AutoCAD so I could get a handle on the Tusk, and was surprised at the complexity, and I think we need help. It's so kind of interesting.
Who understand what he said there?
Yeah. Well, I got a picture for you, like this. So that's the next thing. It's like, okay, wait, I read there's a whole lot of them, so we can draw them out. And if you're in AutoCAD, it's quite easy to buffer those and start drawing that, but it becomes a bit of a difficult task to track. So that's another approach to dealing with fiber data. You can also go in and say, wait a minute, you can realize it's a specialized network. It's going to run through, you could do it through all sorts of related tables. So you literally draw one line and then you can track all the things that go with them because you can do 128 pairs spliced in various directions. And so they come to the conclusion that, they had a fiber outage. It was 7 hours. It took them 4 hours just to try and figure out where the problem was, looking through their data. So, and you can look at tools to deal with that. So the complexity is really about dealing with this kind of thing, where you've got, one strand and then you've got the tubes which are colored and numbered all the way through, and you're trying to build out that network so that you can perform what you'd expect to be able to perform. So you'll look at a map like this, and sometimes it's just a map like this, where you've got, the ducting where it goes, and you're not down to actual conduit, cable, fiber level, and that's where you want to be. So representing it like this is useful because it shows where the things are, but what they are, and trying to draw that splayed out parallel lines diagram becomes completely not doable. If you're going to have 128 splayed out lines, and it's not just 128, it could be, you could have any number of cables and going through there and track from there. And so what you're more trying to look at is think about all the things that you're going to include in mapping and tracking your fiber network. So there's obviously start points, which are often, there'll be a fiber room, typically on a floor in a building, and they'll be coded by whatever coding you're using for those rooms. And then when you're looking at the actual linear network, there's going to be a route, and a route's going to go, there'll be a common route, and it'll have certain branches off of it. And often then the actual fiber can be located within ducts, and you can have ducts within ducts, any number of recursive ducts, how this thing tracks. You'll have nodes. We'll talk about, use the generic term a node, whether that's a vault or whether it's a access point or whether it's a panel or a, or a device. It's still a node. And so you've got to kind of deal with that. And so what you want is tools that allow you to deal with the sort of interaction between these. Fiber is a very difficult data set to deal with because you can splice something that goes from here and it'll change. It's the same connection from this point to that, but it can switch colors and be patched and then go through a different device and be put out for another set of connectivity. And so tracking that is one thing. Just mapping it in the first place is a challenge. The bigger problem is then keeping that up to date, because now if they come and they change the color, how do you reassign it? How do you know which ones have been terminated or not terminated? How do you know which are within, even within a duct? How do you know which duct spacings are spare and available or not, and then go all the way down to spare strands, unassigned strands, etc. So you got to deal with termination, connectivity, splicing, and so being able to confirm that data quality and connectivity is kind of the challenge. So what I'm going to do is pass it over to Johan and let him walk through just these sort of, and we're not going through all the pieces, but we're kind of going to walk through starting at the beginning. How do you capture stuff? How do you build those relationships? And we're using, obviously, examples of where we've been active doing that. Just things like terminating splicing, so you can see that, availability of assignments, and then looking at not just the editing tool, but how can you actually do that in a browser, and can people start looking at connectivity just simply from within a browser. So at that point, I'm going to hand over for you to look at that.
Thank you, Colin. So we'll start off on the data capture component. So I've got some buildings there, and what I'll do is I'll bring in some existing cable route information. Now, we've got a variety of applications, so what we do is we actually get the system to talk the language of the application, so you don't have to go and do all of those kind of things yourself. So what I'm going to do, you can go and place your infrastructure, so vault sites, pits, manholes, and we actually build the relationships between that. So this is some of the that infrastructure that we have. And then you've got the building information as well. So what I'll do is I'll actually go and add a new fiber room, and it's in a building, and it's in a particular room. And so I'll go and add it into that particular building. And we're now going to place I'm going to do a freehand cable route in this case. So just make it fairly easy, so it will do the automated snapping for you. Now what this will do, if I look at the information, it already started to capture some information, but the connectivity is not built yet. So I'll just run an integrity check, and what that will do for us, it will do some calculations, and you can see the colors that tell you whether it's been fixed. And so now that will post that to the database, and that's now in the database, and it automatically built our connectivity for us. So that is then from this room to that room. Now, if I want to go and then capture some data or some, let's say, new fiber cables, I'm going to say, let's define a new cable, and it will go from this point. So that's a new cable. It will then say, now, which route do you want to select? So there's multiple routes that it could take, for example, in a lot of cases, and what it will then reference. What is your cable length? Now, the cable length is always different to the geometry length because they have loops in there. So let's say that's about 150 meters in there. And what is the type? Now, depending on what you choose here, it will give you totally different information. So it captured that cable for us. Now, we actually automatically at that node go and terminated that. So it actually then, so there's the tube, the cable with the 2 tubes and the various strands and all the standard colors that you have.
So how did you get 2 tubes?
When I selected, it was a 24. So what you select as the type, it will automatically populate all of that information for you. If I then want to say, now what have we got in terms of connectivity at this node? So this node, we see there's actually 3 different cables at this node. Now we can see some of these actually have got services on, and if I want to I can go and connect that. So that's actually splicing through this node from one building to another building. So it's actually building that connectivity there for us. And you can see these little icons change. So you immediately can see what is going where. So this is actually going to another location. Those little yellow dots on there tells you that that actually has got a service on. The arrows tells you that it is spliced through. So it's a fairly simple process. Now, it looks quite simple, but there's actually a lot of things going on in the background where it's building the relationships between all of these things. Because if you're going to capture a 512 strand cable, you don't really want to go and do 512 individual geometries then. So my next step in the process is to say, okay, I'm going to add a service from this location. So there's the 1 tube that we've spliced through. And now I can actually go and place a service on that. What is the service type? And you can categories. And so you can go and add services onto the cable, and it's actually built that connectivity for you. So it's a fairly simple process to go and capture the cable if you know what is going on, but then how can we actually use this information? So if I look at a cable, we can actually find quite a lot of different information. So at that particular node, how many strands and how many cables have I got? How many nodes in the building? How many fiber paths in use? So how many of those have got services on at a particular? So this is now in the middle of a cable route that we have identified, and it will tell you that information. And now what have I got available? At which strands can I go and add new services? So it actually tells you what's available at any particular rack, at any particular fiber room that you may want to go and manage the information on. You can also automatically reroute the fiber cables if the route's changed, etc. So that is just a very quick overview of a data capture. And then we want to go and look at the information with this. So there you can see is the new cable that I've captured. So it's live actually reading from a central database. It's not let's go and copy this for a viewing environment. So maybe tomorrow you'll see the information.
So this is a web-based tool looking at the same data?
Correct.
Okay.
So now what we're going to do is show some tracing. So the OTDR, or optical time distance reflect autonomy. So you take a light, you shine it down a particular cable or a strand, and it will tell you where you've got splice losses and connector losses and fiber losses, and it will then tell you how far down this particular fiber path does it work. So what's actually happening here is you're actually going through multiple different fiber cables and joints and splices and connections, and then you've got the various losses, and then so it will tell you you're losing signal, let's say 500 meters or 10 kilometers down this particular fiber path. So when you do these connections, we automatically build those fiber paths in the background. You don't have to manually go and capture that. So that is the one trace. So that will show you. The next trace that I'll also show you, so this is also known as the big yellow cable finding machine trace. So no, these are not carrots. So I think this one, they got the electricity, they've got multiple telecoms, fiber tubes here, so typical type of thing.
When I saw that picture the first time, it took me a while. So that's a core through a concrete base, and they've ripped through a bunch of cables and other things. That you don't want that to happen. And if it does happen, how do you know what's been impacted and what you're going to have to shut off and resplice? So that's obviously one of the use cases right there. When there's a break, and do a trace for that.
The next one is a common route trace. Now this one came about, it's an organization that does all the communication between universities in Australia. So they had two different customers phone them up and say our services are out. These institutions were 120 kilometers apart. And it took them 2 days to find out exactly where that common information, a common connection in between those two different institutions was. Whereas now they can actually do this in about 2 minutes. So we'll show you some of those. So in my browser environment, I can go and let's go to, let's say I'll go to a particular building or a node, and I'm going to do a trace, and depending on what you've selected, it will know what you want to do. Okay, so those same nodes you can actually now go and work through. So that particular node has got one cable route on there. It's got 6 different cables, and on these cables you've got all of these tubes, and these are the strands. So we're actually going to shine light down that particular strand. And so what it will now tell you, on this particular strand, the maximum length there is 190 meters that it could go through. So, and your device saying that is, let's do that, you've got 165 meters from here, you've got the break, and let's trace that down, and it will then tell you that, okay, that is the distance. You've got a tolerance there. So very often you don't know, so they've got loops in the cable, but you don't know on which side it is, so it'll actually go and calculate a tolerance for you on the last cable segment of of the difference between your geometry length and the actual cable length, and give you where you can actually go and look for that particular problem. And it will tell you it's in between these particular nodes, and on which tube can you have you got the problem there. So quite a big time saver there. The next type of thing is the now with the tracing, very often if they break something, so it can either the whole tube is broken, so the cable root is broken, or a particular cable, or anything below that. So if I go and select cable root here and go to my trace, now it can be something like a manhole also that you start this off with. Because I'm doing this locally, it's actually got a timeout going, so sorry for the slight delay that Right, so on this route, it actually calculated. Now, I can go and select the entire route, or I can select any one of these cables within that route. I'll go and select the whole lot. So it'll say these are all the areas that's going to be affected. Let's go and trace that. And then it will start to give me some information. So I've got one cable route, I've got 3 fiber cables, I've got 72 fiber paths. I can, within that cable route, I can say, okay, I've got actually 16 active services there. There's all my 16 active services and which cable does it relate to. So you can easily go and find that information and where that is going. So it will actually tell you these are all the accounts that's affected that you can then go and action. So at any level, you can immediately find exactly who's affected within any of these parts of the network. The third one I spoke about was the common route. So I've got different service IDs. So all I need to do is okay, so between those two, these are the common areas, depending on where the services, if there's certain common areas, it will show that for you, and it will easily go and find that. So it's just an easy and a simple way to actually go and find who and what is affected and how you're going to get to that information.
So the other thing that people have in their cable management systems, or in typical approach, is you're going to have butterfly diagrams for all of the vaults. And so how do I link those, and how do I see those?
Okay, so let's say I've got a particular vault, so I can just go and link to my information here. And there's documents. So I can actually see I've got multiple documents attached to that, and I can then just go and open, find the documentation associated with that to go and link, and you can have however many associated with that. So the whole idea is you can easily get to any of that. You also have all the searches, so you can actually go and search for a document, and from that point it can actually take you to the node that relates to. So you can slice and dice it from either way. You can actually look at the map and get the documentation, or just do a search and find the relevant documentation and then go to the node that it relates to as well.
Yep. Okay. So we just try to highlight the challenges of fiber data and dealing with it, and then just showing a little bit of how that can get used as well. Any questions at this point? Yes.
Can you kind of go through the technology? You drew in Civil 3D, right?
AutoCAD maps Civil 3D, yes.
So how did you get it into the other map, and what are you using?
Sure, and I'm happy to take that question. I try to keep this non-product specific, but it's using our products because obviously that's projects we're familiar with and have been involved in. And the products we're showing here are various customers we've done fiber work for them over the years, and we've productized that now. And so now we actually have this, what you're seeing is off-the-shelf product.
So I guess that was my question. Do you have to use what we saw, like Civil 3D, or
well,
are there other options to draw?
There are various packages that do kind of what we've done. We think we do it better. But the technology you're seeing here, to be specific and answer your question since you did ask, and yeah, I probably should give you some money. Hey? I'm joking. No. So this is a product called Munsys, and there are a number of campuses that use that for capturing certainly their utilities data. It uses CAD for editing, but it stores its data in spatial tables in an Oracle database. They're completely open. Then on the web is another product of ours called Enlighten, which is a web-based framework that looks at the very same database. So this is alive as he's drawing stuff, just a refresh or a pan on the web map, and it's live. It's reading that. So that's our technology stack. That's what I've been showing outside, and we can take that offline. But yeah, okay, good.
I think another aspect too, that all the traces that you see is actually a web service. So you can actually call that web service from another application, and it will return all the values for you.
And coming back to the presentation, it's about fiber data and how do you deal with that. The biggest challenge is that rules-based editing that we were doing. So yeah, in this system, we've already done the entire data model of all the related tables. And if we pull that up, there's probably about 12 different views from 7 different tables in dealing with all of this. So when you click that button and you join it, in the background, we're running a whole lot of triggers that build those relationships and have that so that it looks easy. Because it's like, I just edit it right here and then I go and do this. But every time you're splicing on those dialogues, it's actually tracking and changing all of that info so that it's live in real time. Okay. Any other questions so far? Yes? Yep, that's a good question. So in our products, the documents can be stored. We kind of run we run the gamut as long as the web app knows where those documents are. We can get to them. So what does that mean? It means if it's in a folder, but in IIS, you've mapped that as a virtual drive for the Internet of IIS. Then you'll see that. So I think like that PDF was just mapped to a physical location somewhere on the network. But that could also be a URL document. So if it's in Meridian, for example, you can have a URL that will build that. And in the product here, we allow you to put in a prefix and a suffix. And the prefix would be the name of your server and everything else. And the suffix could be anything. But the actual value, the unique ID of that particular node or cable segment would need to correspond to somewhere in your document management system or one of the fields that you may have within the document management system. So that's how you'll link. And it can be any kind of document. It can be photos, it can be PDF, it can be even a DWG. And so in this case, Johan didn't show it, but in the editing tool, we actually also can have the DWG on that node so that while you're busy editing, you can click on the butterfly diagram and open that in. It opens the actual DWG that you generate, say, the PDF from, if you want, And then you could edit the butterfly diagram there and go back and flip-flop between them. So just to bring, the whole point is make that connected so people aren't trying to manage that in their heads or on scraps of paper or on spreadsheets or whatever. Other questions? All right. Well, fiber is probably, if I had to rank them, fibers, if you look at like a water network's, aside from it being a pressure network, water networks would be probably the easiest to map because it's just dots and lines. And you've got to make it interconnect so it's a pressure and the stuff can flow in the other direction. The next level up would be, say, gravity networks, which are also just dots and lines. So a node or a join point in the network doesn't have, splicing going on. It's going in this direction and it connects, so it's pretty easy. All you got to deal with is the elevations, invert elevations, and flow direction. So that one's a little harder than water. Electrical networks, so if water would be a 1, storm and sewer would be like a 2. If you got an electrical network, you jump up to about a 6. If you get to fiber, you're at about a 10 or a 12 in terms of just relative complexity. This stuff, you lose it pretty quick if you start trying to map that. And so, we've walked through those in building these products to kind of deal with that. And then the whole trace thing becomes interesting. And then also device management and multiplexes and switching connectivity within the device itself is another little ball of wax, but I'll stop right there. Okay, last chance for questions. All right, so I had a question for you then. Let's see, first this guy can get some money here because I've got to give this away before tomorrow. I don't know if you're buying anything tomorrow, but those are good questions. What was the name of the product that was being used for editing? And you're not allowed to answer.
Civil 3D.
That was a good try, but it was wrong. Anyone else? You can have one anyway, just because you answered, yeah. All right, it was called Munsis. So anyway, and what was the name of the web product? The web product that we were using. Wow, you guys were not concentrating, yeah?
Enlighten.
Oh my goodness, gee, got that one. Huh? Anyway, that's not really important. What's the difference between fiber data capture compared to, say, water and sewer networks? Yeah, but what's the difference? It's more complex? Multiple relationships, yeah, and you can have ducts within ducts. You can we actually support unlimited recursive ducts. So you go within this. So all right, I'll take your answer, and I'll take this one over here too. All right, good. Okay, well, thanks very much. Appreciate it, and we'll see you tonight.